Hello friends, this is the last session of the last two videos. This is the third video of the evaporator cooling system. Especially we are discussing the IDEC system, indirect evaporator cooling system. In this video we will discuss the how to design and make the calculation. In this video we will do some case study and the calculation also for the IDEC system, and we will see how first we will do the outlet temperature, how we will get the outlet temperature after the heat exchange or after the cellulose pad. Stage by stage we will see. Suppose we have the dry bulb ambient temperature is 46 degrees centigrade, wet bulb temperature is 26, and dew point temperature is 18.012. So this is the formula what we already seen in our last video. This is the inlet air ambient dry bulb temperature is 46, efficiency we are taking the heat exchanger is 80%, and inlet air dry bulb temperature ambient temperature is 46 and the wet bulb ambient temperature is 26. So answer is came 30 degrees centigrade. This is the outlet temperature after the heat exchanger. This is our first stage. So in IDEC system, as we discussed in our last two videos, the dew point temperature will be remain constant and the specific humidity also will remain constant. So we already got the 30 degrees centigrade in this after the heat exchanger, and dew point temperature will be remain constant. What was the before 18.01? It will remain the same 18.012, and we will see what will be the wet bulb temperature. So we will go now to the second stage of the cellulose pads. The same formula what we use here, same will be here. Now here our dry bulb temperature is the outlet temperature of the heat exchanger. It will be 30 degrees centigrade. Then the efficiency we are taking the 12-inch cellulose pad 90%, then 30, and the wet bulb temperature, if we will see the psychometric charts, at point we have 46 ambient before, and we have the wet bulb temperature 26. So we have the here dew point temperature 18.012. Just we will apply this point. Then we will go to the next. Now we have the dry bulb temperature is 30 and we have the dew point temperature here 18.012. So this is our second point. Just we will connect. So if we will see here, this is the specific humidity line. The specific humidity will remain constant and the dew point temperature will also remain constant. If we will go to the second point, if I will delete this one, and we will go to the second, our 30 and the 18, dew point was constant. How much the wet bulb temperature? 21.740. So this will come the 21 point. How we get the wet bulb temperature? This is the 21.740. So outlet temperature after the cellulose part, which is the second stage of the IDEC system, we got the outlet temperature is 22.6 degrees centigrade. If we use only the DEC system, might we get only the 28, 30, 32 degrees centigrade. By using the two-stage IDEC system, we are getting the outlet temperature 22.6 degrees centigrade. Now we will see how much the efficiency of the system. So we will see the dry bulb temperature was before ambient 46, wet bulb was this one. Dew point temperature we got the 30 degrees centigrade and we got the dew point was constant, and wet bulb we got this one. After the cellulose pad we got the dry bulb temperature 22.6, wet bulb, because in the DEC situation, in the direct evaporator cooling system, the wet bulb temperature will remain constant. So wet bulb temperature 21.7, because this is the adiabatically, enthalpy remain constant and this adiabatically process. So dew point will be changed and wet bulb temperature will be remain constant. Now we will see the efficiency formula. This is the formula what we already seen in our last video. So ambient temperature was outlet, the inlet dry bulb ambient temperature was 46, and outlet temperature, final outlet temperature after the second stage was 22.6. then ambient temperature and wet bulb temperature was 26 divided by 100. We got the 117% efficiency. If we are using the conventional evaporator system, so we are getting the efficiency might be 80%, 75%. We are not getting the 100% efficiency. This is the ideal situation, but in the IDEC system we are getting the efficiency more than 100%. So it is a 107. How much we are saving the energy? It is how much it is efficient. It is more than 100% efficient, this IDEC system. So we will see now basic designing of the evaporator cooling capacity. Now we see how to calculate the airflow in the IDEC system. Whatever the high side coming, we are recommending the air volume. So this is the formula which we discussed. One point is the just the conversion factor from degree centigrade to Fahrenheit. This is the room sensible heat. We have to calculate the room sensible. This is the first method. This is called the heat load method. In heat load method, we are making the heat load calculation normal. We are calculating the solar heat gain, equipment load, lighting load, people load, all the things. Then we are getting only the sensible loads. And this is the formula we are using. This is the first method. It is called the heat load method. The second method is air changes per hour. In the air change, normally like the food industry, the client for the food industry, the air changes is more important as compared to heat load. So it is depend upon the application to application. So this is the air change per hour. This is the formula for the air change per hour. And the third is the air volume. It is the thumb rule. Normally we are taking the 5 CFM per square foot. And we can take for office or factory 3 to 4 CFM per. This is the thumb rule. This is the third method. We will do one case study and we will see where we are getting the higher side airflow. So we will recommend that area. Depend upon the application. Suppose we have the food area. First we will see how much we are keeping the velocity in the air distribution system of the evaporator cooler. Here our velocity are different than air conditioning system, because in air conditioning system air temperature is low and so you need low velocity, but here air temperature is not low like conventional air conditioning system. So velocity are at higher side. And for example, we are taking the main duct, we are taking from 1800 to 2000, branches 1800 to 1500 and terminal 800 to 1000, and we can use the HVLS, high volume low speed fan also. In evaporative cooling system you need to keep the higher velocity. So we will see the next basic designing of the there is sometimes the area is very big and not too many workers are there. Some workers they are working on the plant, so we can give the spot cooling also. So spot cooling just to give the airflow on the head of the people who is working on the plant. So normally if the activity is not generating too much heat, so we can recommend 800 to 1000 CFM per person. If the activity is physical activity is more, so we can recommend 1000 to 1500. If high heat generation, we are recommending 2000 to 2500 CFM per person. It is for the spot cooling when there is the minimum number of worker in the big area of the plant room. Now we will do one case study. Suppose the client he want to maintain that inside temperature is 32 degrees centigrade. So we calculate the room sensible heat. Sensible load is 200,000 BTU per hour. So we will see now how we will calculate the airflow, while the client he need to maintain the inside temperature 32 degrees centigrade. So this is the plant side length, width and height. So as we did the last example, the ambient temperature 46 degree dry bulb and the wet bulb was 26. So we already seen the formula how to calculate our airflow. This is the formula. This we will use the formula to calculate the airflow. Just we will put the value here in this formula. So this is our heat load. 1.8 is the conversion factor. This is the temperature what we need to maintain, and this is the temperature what we get after the heat exchanger. This is the temperature. Here in the heat load calculation, first we are using, if we are using the conventional evaporator cooler. So this is the calculation for the conventional evaporator cooler by heat load method. So we need 25,720 CFM to maintain, if we client want to maintain the temperature 32 degrees centigrade, because outlet temperature here is 28 degrees centigrade. If we are using the two-stage IDEC system, so here our outlet temperature will be 22.6 degrees centigrade as we did the example in our last slides. So now the CFM will come 10,944. If this is not food industry, it is like a warehouse or office area or the mall. So if we make the comparison in two, so see how much the huge energy we are saving in the shape of the airflow. So we need the less airflow as compared to DEC system. So we will go now for air change method. Suppose we are using the 10 air changes. So A's total CFM is coming 18,750 and the thumb rule is coming total CFM. We are taking the 4 CFM per square feet and we are multiplying by area. We are getting total CFM 22,500 CFM. So if we will see, this is 22,000, 18,750 and 10,000 and 25. So we will go for the highest airflow. So this is the highest airflow. This because this is a food area. So we will go for the higher airflow. This is that is 22,500 CFM by using the thumb rule, and we will use the DEC system. Not important is the IDEC system because the air changes are more important. So we will go now next case study. Here the client, he wants same case study, but client want to maintain inside temperature is 28 degrees centigrade. So same calculations we will do. Dry bulb, ambient temperature, wet bulb. Here if we use the DEC system only, we are getting the airflow 102,880 CFM. But if we use the IDEC system and our outlet temperature 23, we just need 20,576 CFM. Here is the huge difference, how much we are saving the energy and how much we are saving in the evaporator cooler machines. Huge saving. And this is the example, like it is not a food area. Air changes are not important. Just we have to reduce the temperature, we have to maintain the temperature is important. So these two calculation, the heat load calculation, if we using the just conventional desert evaporator cooler and if we use the IDEC cooler, 2 stages. So here we will see now for the exhaust system. It is a once through system. There is no return. If there will be no exhaust system, slowly latent heat will get increase and you will not feel comfort. In conventional AC, 90% return air is coming back and 10% only fresh air. So for the exhaust system, we have to use there is a options. We can use a roof extractor or natural motorized dampers or opening, and we can use the louvers in the shape of the opening in the wall, or we can use the force mechanical system, the exhaust fan in this third option, because if you use the exhaust fan, the power consumption again will be increased. So we will prefer to use the louvers or the natural extractors. Now we will see if we will use the IDEC system as a pre-cooled system. For example, we have the building and we are using the DEC chilled water system, conventional air conditioning system, and we are getting the fresh air. If we use the IDEC system just to cool the fresh air, and we will give the cool fresh air to our AHUs so that the cooling coil and the AHU size will be also decrease. So how we will do? Like here we have the heat exchanger. Air is ambient 26, 46 dry bulb temperature, 26 wet bulb temperature. After the heat exchanger, outlet temperature is dry bulb 30 and wet bulb temperature 20, as we did the example our last pages. The outlet temperature, wet bulb temperature, how we get the wet bulb temperature 21.74, because the dew point temperature will remain constant, this because no moisture added in the heat exchanger. If no moisture added, the dew point temperature and specific humidity will remain constant. So with using the psychometric chart, 30 degree dry bulb and the dew point, what we get from here, the wet bulb, we will get the wet bulb temperature. After the second stage, the cellulose pad, we are getting the dry bulb temperature 22 points and wet bulb temperature will remain constant because of the constant enthalpy process, adiabatic process. So this is the indirect evaporator cooling we can use just to cool the fresh air. If we will use the conventional evaporator cooler system, the wet bulb temperature will be remain constant. If we will see, the wet bulb temperature will remain constant, and this is the specific humidity, the moisture in the air. If we will see the specific humidity at this level, and now we will see the specific humidity will be increased. For example, we have the air 40 degrees centigrade and 24 wet bulb temperature, and the specific humidity 13.56. If we reduce the temperature up to 25.6, from 40 to 25.6 degrees centigrade, wet bulb temperature will be remain constant. See how much the specific humidity increase. So our latent load will be increased, the more moisture will be in the air. Now our specific humidity will be increased. But if we use the IDEC system, our ambient condition was this one, And now our dry bulb temperature will be more cool. Wet bulb temperature will, we also decrease the wet bulb temperature, because just we did the heat exchanger process, because no moisture added here up to here. The sensible heat it reduced, dew point temperature constant, specific humidity constant. After this one we did the conventional evaporator DEC system. So here the moisture added, but moisture is not added like before. Here moisture is added more, and but here moisture is added 60% less. So in the IDEC system, up to 60% less moisture added, and we are getting the more cooling also by the IDEC system. Here we are getting the outlet temperature 25.6, and here we are getting the outlet temperature 21.2. The application of the IDEC system is like factory, assembly line, injection molding, welding, pharmaceutical, especially in the warehouse area, panel room cooling. Panel room, there is too much heat dissipation in conventional air. In the conventional air conditioning system, you will get to use huge amount of energy in panel room. 30 degrees centigrade is a good temperature to maintain in the panel room. So IDEC is a good option. Where is more people, IDEC is a better option, because oxygen level will be also maintained, and the more oxygen will become and more fresh air will become. Like in the dining area and kitchen area, you are taking the return air, and there will be a food smell, it will be circulate all the dining area. So IDEC is more preferable in the dining and the kitchen area also, and these are the page for the application, where the IDEC application also. So now we will see the example how to use to pre-cool the fresh air, how to cool the fresh air. Suppose this is the AHU, and this is we have the coil. If we use IDEC heat exchanger, only IDEC, there is no cellulose pads, only one stage IDEC system, just we reduce the heat sensibly, we reduce the temperature, no moisture added. So we can use the IDEC in direct evaporator cooling system to cool the fresh air. And we can, so in this case the cooling coil of our AHU will be have the less load, and the size of the cooling coil also will be reduced. Suppose we have the 1000 CFM. If 1000 CFM and we have the ambient condition 40 degrees centigrade, and we want to bring the temperature is 16 degrees centigrade, so we need the conventional air conditioning 4.6 tons of refrigeration to bring the 1000 CFM to 40 to 16 degrees centigrade. But if we use the combination of IDEC system, in the IDEC system from 40 we can bring the temperature 27.2. Sensibly we can reduce the temperature. After this one we can reduce the our DEC or chilled water system. For example, if I use the IDEC system here, and I will bring the temperature from 40 to 27.2 degrees centigrade, we can, so it will be total, it need 2.5 tons of refrigeration if we use the IDEC system. So we save the 2.1. So this 2.1 we can add in the coil load of the DEC or chilled water system. So we save the 2.5 tonnage by using the IDEC system. So we can save the huge energy if we cool the fresh air before coming to the cooling coil. So there is a different models how to use the IDEC system. Suppose this is the ambient air, and this is the the pre-cooled unit. By IDEC system we will cool the fresh air, and the fresh air is directly supplied to the central conditioning space, and AHU is supplying the separate cooling coil and giving the conditioning, the cooled air in the conditioning space also. So in this case the fresh air is coming after the cooling of the indirect evaporator cooling system. The other model is we cool the fresh air and we give to the AHU, and AHU is supplying the return air and the cool fresh air to the centrally conditioned space. And the third scenario, we are cooling the fresh air and we are giving the cool fresh air to treated fresh air, and AHU is supplying separate, and treated fresh air unit is supplying the separate airflow to the conditioning space. So this is the three scenario how we can use our indirect evaporator cooling system just to cool the fresh air and give to the direct to the AHU or treated fresh air units. Application, this is already we discussed also the different application in the hotel, shopping mall, hospital, pharmaceutical, warehouses, process, data center, kitchens, malls, residentials. So energy saving solution we will see now. Now we will see the hybrid system. How we can use the hybrid. What is the hybrid system? Hybrid system is the three-stage system. In the first stage we will use the heat exchanger where we are not adding any moisture, just we are reducing the sensible heat. In the second stage, we will use the DX or chilled water conventional AC coil, and third stage we will use the cellulose pads. The area where is the more humidity, more humid area, we can use only the DX or chilled water coil and the heat exchanger. Two stages, we will not use the cellulose pads. If the humidity is decreased some month, for example, some area they have the wet bulb temperature from March, April, May, June, they have the wet bulb temperature nearly 20 to 23 degrees centigrade. So we will not use the DX coil and the chilled water coil. We will use only the heat exchanger just to reduce the sensible load of the air without adding any moisture, and we will use the cellulose pads. If the humidity increase and the wet bulb temperature also increase, so we will shut down. We can use our inside area, the humidity sensor. If the humidity increase more than 70%, the cellulose water supply will be shut down. Only we will use the DX coil and the heat exchanger. These two coil we will use. So this is the hybrid air conditioner. We can use different way. If we see this diagram, this is the cool, like winter, fresh air is coming, 100% fresh air is coming. This is the heat exchanger. How we can use this heat exchanger, like ambient hot air is coming. The first situation, there is wet bulb temperature is good, not too much humidity, so we can use the heat exchanger and the cellulose pads, and we can use the 100% fresh air. We can cool the air in this method. Suppose we can use this heat exchanger just to cool the fresh air. We can use this method. And suppose we are taking the return air and there is the humidity, wet bulb temperature is more, so we will use the heat exchanger and the DX or chilled water coil just to cool our place. So this is a different application. Of course, there is a need a control, the motorized damper, complicated system. This system can be applicable, little bit complicated. It needs some control solution also. So types of the hybrid system. Hybrid system can be with the return air, but it is more complicated, need motorized damper, the sensor, the humidity sensor, the temperature sensor. So we can use the hybrid system. This is the heat exchanger, this is the DX or chilled water coil, and this is the cellulose pads, and this is the fresh air. If we want just to cool the fresh air, and we will give the three stages IDEC system. The first stage is heat exchanger, then is the DX or chilled water coil, and this is the cellulose pads. And we can use this system, mostly this system is used, we can use this system by application. If the more humidity, more wet bulb temperature, we can close the third stage and we can use just the two stages. Operation and maintenance. Regarding the operation and maintenance, if you are using high TDS water distribution pipes will be choke. These pipes are important because these pipes used to distribute water on heat exchanger. Generally, we are using the formic acid. It will do descaling of your heat exchanger. So the maintenance is very important. We have to do the weekly cleaning of pre-filter and water sump, regularly cleaning of the overhead water distribution pipes, which I said we can use the formic acid. Water quality recommend TDS less than 500 ppm, hardness less than 100 ppm, and the pH less than 8.5. So we can use the wire brush for the hard scaling removing, for belt driven fan check, belt tension every 3 months, apply proper grease on the fan and motor assembly, do anti-rust paint on exposed GIM. So this is the maintenance. In the IDEC system, there is not too much maintenance as compared to conventional air conditioning system. Here is just the pumps, small pumps, and the pads, and we can control by using the formic acid. We can control the scaling also. We can maintain the good pH of the water. But like conventional air conditioning, there are many controls involved, like compressor, condenser, evaporator, many things. There is much maintenance. So in the IDEC system, we can save too much money as compared to the conventional air conditioning in the maintenance also. So this is the last slide, and we discuss how to design, how to maintenance, how we can keep the velocity, how to get the outlet temperature, how to design by airflow. So by using the IDEC system. So thank you very much.